Okay, everyone. Just so you know, I'm using a new computer to record off of now, so I'm hoping everything goes well and that we don't have any issues. So this is the first video lesson for 8th grade math for the week. We're going to start getting into the last module, and we're going to spend pretty much the rest of the school year talking about it and then doing some reviewing at the end if we have time. Today we're going to start by going over Pythagorean Theorem. Some of you have probably heard of this before, and maybe some of you have looked at this in other math classes, but today we're going to be focused on just it. Now, Pythagorean theorem is used to analyze right triangles. It's a very useful formula that can be used to do many different things when you're looking at one of these right triangles. So first, let's look at what the theorem looks like and how we can identify what the different values or variables stand for. So if you take a look here, here is the Pythagorean theorem. Let me change my color real quick, guys. So here is the Pythagorean theorem right here. And it consists of the following. A squared plus b squared equals c squared. So we can use this theorem in order to find the value of a, b, or c, given that we have two of the other values. So if I have a and b, I can find c. If I have b and c, I can find a. And if I have a and c, I can find b. So A and B, there's not a lot of distinction between them other than the fact that they are called the two legs of the right triangle. They are the two sides that make up the right angle. So if you'll look, sides A and B meet where the right angle is. So that's how we know they're the legs. And then we also have C. C has a special name when we're working with right triangles, and if you've never heard it before, that is this word right here, the hypotenuse. This is a very important term that you need to familiarize yourself with. So C is our hypotenuse here. How to know which side is C is it's always going to be the side that is opposite of the right angle. So if you look here, C is on the opposite side. Also, it is always the longest side of the right triangle. So if you're trying to work one of these problems out and you find that A or B is longer than C, then you've made some kind of mistake. All right, so that pretty much covers what I wanted to start out with on talking about the theorem itself. Now, another very important topic for today's lesson is we need to be looking at perfect squares. This is an idea we were introduced to at the beginning of the year when we first started talking about using exponents, but this is a very special set of numbers, all raised to the second power or squared, and we call them the perfect squares. It's the numbers that are all a whole number multiplied times itself. So if you look, I have 1 squared is equal to 1, which means 1 times 1, because remember, whenever you are doing exponents, it just means repeated multiplication. So on all these, we have the same number being multiplied times itself. So 1 squared is 1 times 1, which is equal to 1. And then we'll have this pattern and it will continue. 2 times 2 is equal to 4. 3 times 3 is equal to 9. 4 squared is 16. 5 squared is 25. 6 squared is 36. 7 squared is 49. 8 squared is 64. 9 squared is 81. 10 squared is 100. 11 squared is 121. And 12 squared is 144. And this continues and continues and continues. I would recommend you probably make yourself a list all the way from 1 through 20 and keep it in your notes because it will become very useful to you in the next few lessons that we do this week and next week when we're going to start working more closely with this concept. Now, today, the biggest thing I want you guys to be able to recognize is if a number falls in between the perfect squares. Now, the perfect squares, when I say that term, I'm referring to the answers to these questions. So 1, 4, 9, 16, 25, so on and so forth. Those are the numbers that I consider to be called perfect squares. On today's lesson, on part of it, you will need to be able to identify what two perfect squares a number falls in between. And then in the next lesson on Thursday, we'll go more in depth on why we're doing that and what that means for us. Okay, so if you haven't yet, I'd take a moment to pause the video and copy down this chart for yourself. That way you'll have it for your own use. And I am going to get us over to our two example problems I'm going to do from the lesson. Okay. Hold on, let me get this fixed. Okay. You guys should be able to see what I'm seeing now. A little bit of a hiccup in transition from tab to tab there. So let's take a look at the first question from this lesson. And it is just going to be, we're going to start with number 1 and go from there. Number 1 says, use the Pythagorean theorem to estimate the length of the unknown side of the right triangle. Explain why your estimate makes sense. So the first thing I'm going to do is I'm going to write down the theorem for myself. I have a squared plus b squared is equal to c squared. So when I am trying to find an unknown or missing side length of a right triangle, the first thing I have to do is I need to identify which side is missing. So remember those things I talked about on the last page where we were looking at how to identify which sides are A, B, and C. A and B are the legs. They are the two sides that join together to make the right angle. So in our triangle here, it's going to be this side here and the side that says it's 13 inches long. So I can tell that our unknown or missing side is one of the legs because I have a value for the hypotenuse, side C. So what I'm going to do is I'm going to substitute in the two values I have, 13 and 15, and I'm going to leave a squared blank and say that a is the value I'm trying to find. So here I will have this. I want you to take a second and pause the video and try to write this before I do and see what you come up with, and then check yourself with mine. Okay, so as you can see here in red, I have a squared plus 13 squared equals 15 squared. I've replaced b with the value of 13, and I've replaced c, the hypotenuse, with the value of 15. And now I'm going to try to solve for a to find the unknown side. Now, the reason we're saying we're going to estimate this is because the number won't always come out perfect or as something we recognize easily. So keep that in mind. Now, let's go ahead and let's look at how to solve this. So the first thing I need to do in trying to solve this equation is I need to see if there's anything I can simplify or make it easier to work out. And I see that I could go ahead and do these exponents. I could do 13 squared and I can do 15 squared. So I want you guys to go ahead and figure out what those two are and try to rewrite the next step of the equation. Go ahead and pause the video. Okay, so these two perfect squares, 13 squared is 169, 15 squared is 225. That's why I said you might want to go ahead and fill out that chart all the way from 1 through 20, because we're going to use some numbers other than just 1 through 12, obviously. So here we have a squared plus 169 equals 225. What would be, you need to try to remember what would be the next step in solving this equation. So take a second to think on that. I'm hoping what you came up with was that we needed to subtract 169 since it's being added. So that's what I'm going to go ahead and do now is subtract 169 from both sides. Now, from there, we're going to get that a squared is equal to a number. That number is 56. So far we have a squared equals 56. But now I want to ask yourself, is 56 a perfect square? Think about that for a second and then tell me what your answer is. I'm hoping you said no, because there's no number that if you multiply times itself, doing repeated multiplication, that would equal 56. So let's try to think of what two perfect squares 56 falls in between. So if you think back or are looking at your chart, you should know that 7 squared equals 49. I know this fact right here. Sorry, working with this new touchpad here is a little difficult. And then 8 squared is 64. The number 56 is in between both of these numbers. So what I can say about a squared is that it is a number between 7 and 8. So that's what we would mean by estimating what the side length is equal to currently. In our next lesson, we will be looking at how to find that find a better approximation, you could say. But for today, we can just leave it as A is between 7 and 8. So I'm going to go ahead and pause the video and write what I would like for you guys to put as your answers on these when appropriate. And okay, that way you guys can see it. What I have here for the answer is A is between 7 and 8. So that's what I'd like for you guys to do with them in this lesson. I'm going to go ahead and do one more example for you to help you out. I'll do number 2 with you as well, and then you'll need to work out the problems on the second page by yourself. So give me just a moment to get this cleared off so we can look at it. Okay, so let's take a look at the second problem. Once again, we'll use the same Pythagorean theorem, a squared plus b squared equals c squared. And once again, it wants us to find the length of the unknown side. So let's try to identify the sides. Well, let's look and see where the right angle is. The right angle is right here. And it looks like I have the value of the sides of how long they are for the two that make the right angle. So the side we're missing is the side opposite of the right angle, which is the hypotenuse, or C. So I'm going to go ahead and plug in the values of 4 and 12 where they would need to go in the theorem. I'd like for you guys to pause the video and do the same and see if you plug them in correctly. Okay, so hoping that you plugged 4 and 12 in for the legs. Now, if you did it backwards, that would still be fine. The problem would still work out correctly. You could have put 12 and then 4, or you could have written it how I have here. So now we're going to go ahead and once again see if there's any way we can simplify this equation or make it easier to work through. So I'm going to start by doing the exponents with these two numbers. So I know that 4 squared is 16. And I know that 12 squared is 144. Those are two of our, should be hopefully easy to remember, perfect squares. So that's what I have so far. And now, my next step, hopefully you guys see it pretty obviously, is just to add these two numbers together. 16 plus 144. We'd like for you guys to go ahead and pause the video and write what the next step would look like. Hoping you guys realize this is 160. So we have 160 is equal to c squared. Okay, so that's pretty close to where we're going to leave this one for today. But the last thing I want to do is let's do that same process of estimating it like we did on the last one. So let's look at what two perfect squares the number 160 is in between. And let's say that c is in between those two numbers. Because if c was a number being multiplied times itself to equal 100, it would need to equal 160. So let's see which two ones we can estimate it's in between. So I know that 144 is 12 squared. We know that one. That one's pretty easy. And in case you can't remember from the last problem, 13 squared is 169. So if you look, 160 is going to be in between these two perfect squares, 144 and 169. So we can say that C is between 12 and 13. Now we'll look at trying to find a more exact answer to these questions and even better estimates in the following lessons. But for this one, this is as far as you guys need to take it. All right, if you guys have any questions about this video or need anything to help you finish this lesson, please, please, please email me or leave it in the comments. That way I know you guys need it. I will be in touch with some people over the phone to check in on how everyone's doing this week, and I hope to hear from some of your parents this week. All right, you guys have a good rest of your day.